There we go. Hey, YouTube, I'm sorry. Last week, I was able to push one button. The week before that, I had to push two buttons. And this week, I had to push two buttons again. And I'm all screwed up. So, welcome to the PFG Live for Sunday. So if you're not a machinist, you're welcome. If you are a machinist, you're also welcome, but you're required to contribute. You may recall that in the last week or so, the last couple of weeks, we ran a contest. And that contest was to count the number of boxes in the bag. So there was a great big bag, and it was full of boxes from the raw materials that I buy from Norton to make PFG stones. And hey Carl, welcome aboard. Sorry for 8 minutes late on YouTube. That was my fault. So over some period of time, which I honestly cannot tell you what it was because I don't remember, I started collecting these boxes in a big trash bag. And the idea was, hey, I could reuse these boxes and I can maybe recycle these boxes, but I didn't think about it too much. Hey, RJ's Workshop from Wyoming. Welcome aboard, sir. Nice to see you. I hope you're having a great morning in Wyoming. Hey, Wyoming, I got to tell you something. New Hampshire was 76 degrees yesterday. And I think today is going to be the same. Mr. Walla, welcome aboard. So we started accumulating this huge garbage bag full of boxes, and we made a contest out of it. And last week, we had the counting of the boxes. And I made a fun video with my son, and we, in fact, counted all the boxes in the bag and made a little video and announced the winner. And I think I just want to review that with you guys right now. Welcome aboard, sir. Unfortunately, I can't read Russian, but welcome. You had 70. So RJ's Workshop in Wyoming reports that they had 76 mile-an-hour winds yesterday. Yeah, pretty crazy. Definitely great is typing with two hands. Excellent. So you have to go watch that video. It's under 2 minutes long, but it's a lot of fun, where we counted the boxes. And the magic number was 396, which if you're on Instagram, this says, okay? And we displayed our work. That was our counting. My son Jared double-checked my accounting, and we all agreed. And once we all agreed, we locked it down. So the winner is Kevin Howard. Can somebody give me some translations of what's going on there? I would appreciate it. No translation. If I don't understand what you're saying, that bothers me. We don't want that. Kevin Howard guessed 390. We had 396. Wicked close. He was the closest one. And then I did a little research because I'm like, boy, his name is really familiar. And sure enough, he is a customer. So he is getting another set. But he hasn't contacted me yet. Kevin, you have to call me. Give me a call. And we will take care of you. Talgat 191-811. Would you please either post in English or somebody translate for me, because I can't understand what you're saying. All right, so the contest was a success. It was a lot of fun, and I was able to get more shop space by taking that big bag of boxes over to recycling, and they have been recycled. Mark's Engineering, welcome. Good morning. Happy Sunday. So that was the contest and our contest winner. So if anybody talks to Kevin, let me know. So we can get into it. Mr. Bolivera, welcome aboard. So we've had a project going which really has turned into an educational experience. Our good friend, the pragmatic machinist, gave me a project to do. In fact, let me grab his drawing. Chris needed a simple yet robust gauge for checking some of the work that he does professionally in terms of fire suppression pumps, lining up some shafts. So he came up with a design, I drew the design, and that's what we've been working on. But because Chris is so patient, we turned his project into an educational experience. Wes, you're early today. I tried to tell everybody. I really did. Twice. So Chris's project starts with a blank of A2 tool steel. 6 inches plus, 1 inch plus, an eighth of an inch thick plus. So it's an oversized piece of A2 steel. We cut them up, we deburred it, dressed the sides, and made it ready to go to the next step. So because this is a pretty simple gauge, there's no other work to do in the unhardened state. So normally, if you were making a part that had some machining to be done, you could do the machining here, or you could send it to Laney Machine Tech, and they could machine it on their Kern in the hardened state. I just got your work, Adam. So we're ready to harden this. So we got clever, and that's a mistake. We hardened it. Oh, Kazakhstan! Thank you very much. Well, welcome, Kazakhstan. You're welcome to join us. So the parts were put into the oven. Unfortunately, we put all 5 parts into a pouch on batch number 1 with no particular thought about how they were sitting spaced next to each other, nothing else. And they came out, metallurgically, they came out okay, but they all were stuck to each other. So in my panic, trying to get them apart, we ended up bending the parts, and which is not hard to do when the parts are red hot. So batch number 1 was dimensionally a disaster, and it turns out metallurgically they came out pretty nice. Also on batch number 1, we cut the pouch open and tried to dump the parts out. Remember that. So batch number 2, we got smarter, and batch number 2 we looked for a solution for sticking the parts together. So the first thing we learned is knife makers like to use talc in their pouches to keep things from sticking, part to part, part to pouch. I didn't have talc, so we used 5-micron lapping grit, which is aluminum oxide, and it was a blazing success. The 5-micron aluminum oxide has the mechanical consistency of confectioner's sugar. So if you've ever eaten a sugar donut, guten Abend from Germany. Welcome aboard. Microbe. Microbe. I like it. Welcome. So the 5-micron aluminum oxide, we took a little tray. Okay, you can still see it in there. And we put our parts in, and we painted the 5-micron aluminum oxide on with an acid brush, and it stuck really well. It was very much like putting confectioner's sugar on a donut. Once it's on, it's on. And that's what it felt like, which was weird, but it worked. And then it went 1 blade per pouch, and then we went into heat treating with the vertical file folder technique, and they came out, and then they went on the cooling rack, and we kept them in the pouch, and we let them quench in the pouch. Overall, so the 5-micron grit was a success, absolutely. Quenching them in the pouch was a success with a proviso. I will talk about that in a second. The parts came out. There's pictures on on the YouTube and on Instagram. And they came out gorgeous. They had no coloration. So notice the first batch, when it came out of the envelope and we were wrestling with it, it came out and it got colored. The ones that came out with the pouch intact came out with no color. It was gorgeous. Then we proceeded. Let's see, 5 micron. Yeah. So one of the comments I got back from, we're still in summary mode here. One of the comments I got back from Robin was, "Where's your fan?" Right. So I told him I was his biggest fan, and he recommended having a fan blowing on the parts with thought, not randomly. So the next batch, we're going to have the parts in their envelopes vertically, and we're going to have a fan blowing this way and just keeping the air moving to get the quench rate faster. And Robin and I talked about that on the phone, and I'm convinced that is a fine thing to do, as long as you don't do it the wrong way. Now, the wrong way would have been to pull the pouches out and blow a fan on it this way. Okay? We'll explain that in a second, Art. If we blow on the parts this way and this surface cools faster than this surface, you're inviting warping. So this is, we're trying to avoid that like the plague. So the next time we will use a fan. Also, knife makers are known to take their blades in the pouch right out of heat treat and go right into a double plate quench, where they'll put it between two metal plates. Some of them will put some pressure on them with an arbor press and quench them flat under pressure, and that's how they deal with that. I don't want to do that. And I don't want to do that because if we're making a bunch of parts, now you have to pull each one out and quench between plates. Yeah, so wallet tool, Aaron brings up, he says, never mind. This is the beauty of lag, Aaron. So he says, you don't use quench plates? Aluminum plates seem to be favored by my knife maker friends. Yes, no problem. But if I'm making 20 of something, it ain't going to work. So I'm trying to avoid that. So, and we had good indications that our process was starting to get better and better, which brings us to batch number 2. So in batch number 2, we stacked the parts vertically in the oven. We made fire brick. I call them 1, 2, 3 blocks in fire brick. They weren't exactly 1, 2, 3. And the 1, 2, 3 blocks, sorry about that. The 1, 2, 3 blocks kept them stacked like vertical cards. Wes says, if we're surface grinding the whole thing, why worry about oxidation? We're not really worried about oxidation. So the oxidation is a metric of how good your pouch is working. We're not worried about oxidation, as you're about to learn. But we are worried about warping. So, in batch number 2, we did the vertical file folder thing. That worked really well. And the parts had very little warp. And when they came out of the pouches, even though Wes, I know we're not worried about it, they had very little color. And we were able to get into surface grinding. Now, here's where I had I made a mistake. I made a mistake because somewhere in my learning and talking to others, mechanical straightening was a useful tool. And I mechanically straightened at this point. This was a mistake. And the reason is the act of mechanical straightening, which is where you take a part, it says, hey, you're 3/1000ths out of flat, and you put it into a bending jig, and you bend it the other way, and you let it relax, and you measure it again, and maybe it comes out 1/1000th, and you say, oh, how brilliant am I? Or even worse, you go in, like this one is 15 thousandths out at the moment. So I could say, well, if I can get this from 15 thousandths out down to 1/1000ths out, isn't that great? It's great, except for one thing. The reason bending, mechanical straightening works is because you're intentionally putting stresses in the part. And those stresses make the part straight. Now, let's just do a little thought experiment. I want you to imagine that you go to Home Depot and you buy a 2x4 and it's not straight. I know, crazy, right? And you put a nail in the top, you put a nail in the bottom, and you put a cable between those two nails on the side that you want to bend it to, and you put a little turnbuckle. And you turn the turnbuckle, and it goes, and it can straighten your 2x4. So now you have a 2x4 with a cable on the side, and it is all perfectly straight. So my question to you is, what happens if I cut the cable? It goes back. It goes back to being warped. Well, the act of bending a part is putting stresses into that part which are analogous to the cable on the side of the 2x4 straightening the part. So here I was thinking I was doing something smart, took the part, mechanically straightened things, got them pretty straight. Now I said, hey, now I'm ready for surface grinding. So as soon as I surface ground them, they moved, okay? And it did not get me closer to my goal. And once that stress, once you've bent, hey, K-Bonk, welcome aboard, sir. Once you've bent that stress into the part, it's not coming out. There's the problem. So all of the grinding cycles, yeah, you do want to yield the part. So I know where you're going, deflagrate. I may be using the term stress, not exactly precisely, but it's close enough. When you go to bend it, if you don't yield the part, you don't put a permanent change in it. But if you yield the part just the right amount, you can bend it back to straight. But what I'm saying is, if you do that, you've made a change in the part that is going to come back out when you grind it. And here's why. Because the effect. Yes. So Wes says, can you anneal them, straighten them, then reharden them? Yeah, of course. But I don't want to do that. I was trying to get out of the hole I dug without doing that. There's a reason. The reason is education. Okay? Excuse me, I'm just getting rid of a thing. There we go. So everything that came after that was me fighting the stresses I put into the part because of bending. And it was not pretty. The other thing I learned was that if you support a part near its ends, right, with a rod, and then you push on the part with another rod. I was using pins, and you push on the part in the middle with pins, and you put that in your press. You would think that you're going to get this nice bend, and everything is hunky-dory. In a perfect world, you would. But my measurements indicated that the stresses were not, first order. Technically second order, but they were not first order. I got W shapes in my parts. And when I talked to Robin, he was unsurprised. So we talked about how to avoid that sort of thing. But basically, it was a mistake trying mechanical straightening at that point in the process. And I'm going to talk in a second about what I'm going to do in batch number 3. But I just want to say that mechanical straightening has a place, but its place is at the end of the process. A very good knife maker that I've talked to says that they do mechanical straightening and then they go to lapping, and they might be doing, taking tenths off. and they're happy with that process. But grinding thousandths off after mechanical straightening did not work. Henry says, I would straighten the parts after grinding all the features. Yeah, that's what we just said. Absolutely. Okay. So that was the story of mechanical straightening. I'm just checking my list. We talked about heat treating. So after a bunch of grinding, we got adequately decent results on the part. Yeah. Wes says it looks like crispy bacon. It is crispy bacon. So we'll talk about this in a second. You're getting ahead of me. So we ground the parts and we used a few tricks. We're going to talk about those tricks, and then they went into the next part of the process. So let's talk about the tricks we used. The first trick we used was the paper towel trick. So the paper towel trick, I still think, and I talked to Adam the machinist, Adam Demuth. I talked to Adam about this at some length, and I still think there's a little mystery around the paper towel trick. And I will now present to you my model of what the paper towel trick does. So you take a part that is out of flat, and it could be arbitrarily out of flat. It could have a W in it. It can have a curvature in two axes. It could be a potato chip within limits. Okay. You put the part down on a paper towel. Also, Steve Barton of Solid Rock Machine Shop also demonstrates this on a video, which is now in my grinding videos playlist on Kinetic Precision. So you put the part on a paper towel, you soak the paper towel with coolant, and you turn your magnet on, and the coolant saturated paper towel acts like a cushion, and it takes up some of the room under the part, and you can go in now and you can grind that part, and you can get a flat surface on that part with very little, not zero, but very little distortion from the magnet. Adam Demuth said to me wisely that it was about a 90% solution, and that was kind of what I was observing. It's pretty neat, and here I have to report to you some of my observations. While I was doing the paper towel trick, and I got to the point where I was sparking out, it never sparked out. So what I think happens when you do the paper towel trick is the part actually can move. And as you take stresses, as you grind stresses away from the part, and the part wants to bend a little bit, it bends. And by the time you are, down to, a tenth or trying to spark it out, it has worked its stresses out, and it's moved a little bit, and you've got a pretty flat surface. Not perfect, but way better than you started with. And then you could take the part and flip it over and put it hard on the magnet and do the other side, and you've got, ideally, you've got a flat and parallel part. Here's the problem with the paper towel trick. Actually, the paper towel trick works great. It is a 90% solution. Of course, you could also do it twice. What's 90% times 90%? So, or, God, you could pick on me for that. So the paper towel trick is a magnet-on trick. If you have control of your magnet, you can add just enough magnet with the paper towel trick, and it works. I saw really good results with the paper towel trick. The problem is, if you have internal stresses in your part, the paper towel trick will allow the part to move during the process. 81%. Of course, that's not what I meant, Tuck. What's 0.99? No, 0.90 times 0.90. Never mind. That's not what I mean. We're getting distracted here. Hey, Bob Labs, welcome aboard. Turn right machine. Howdy, neighbor. You should come up here one day and be a guest live and in person. Okay, so I call the paper towel trick a success. I am so glad that Turn Right Machine showed up, because I was thinking about you as an example. So Turn Right Machine takes shafts which are not straight, and he straightens them, and he does so magnificently. And he does so using heat from a torch and then rapid cooling from his special air and water jig, and his rollers and his indicators, and he is able to take a long marine shaft of shaft steel and make that sucker damn straight. But when Keith does this, what is he doing? He's putting little stresses in to straighten the part. That's the whole purpose, right? So earlier, you might not have been here, Keith, when I gave this analogy. If you have the 2x4 with a cable along the side and you're turning the turnbuckle to get your 2x4 straight, the analogy is that Keith is putting in a little stressor to pull the shaft straight. And it's the last thing he does. So you'll notice, if you watch Keith's excellent videos on shaft straightening, he doesn't straighten the shaft and then grind the shaft down to make it nice and smooth, or put it in the mill and grind everything off, because he would be cutting out the little intentional stressors that he put in. So all of this is in the same family, okay? So if you have internal stresses in a part and you do the paper towel trick and you say, oh, how smart am I? And you measure the surface you just ground, which I did, and it comes out great. It was less than 3/10. I was super happy. You flip it over, you put it hard on the magnet, and then you take that top surface off. Guess what happens? You've removed stress from the part, and it smiles again, or frowns, or something. It moves. So the ideal situation is to have as stress-free a part as you can have. And the question I have is, can you have a hardened part that has no stresses in it? And I think the answer is probably no, because as you cool the part, it cools from the outside in, and I think you end up with stresses essentially in the skin of the part. And no matter what you do, you have some stresses to deal with. Of course, I built in the stresses because I did mechanical straightening early in the process instead of at the end of the process. That's mechanical straightening, and that's some of what I've learned about applying mechanical straightening. So, so after we did a whole bunch of grinding, I decided we were going to go into a cryo treatment. Now, I heard somebody say it's a stabilization process. I got a thumbs up from Keith. Thank you, sir. By the way, in addition to thumbs ups, you can also slap me in the face if I'm saying something stupid. I'm totally open to that. So I decided to go into a cryo treatment, and I got myself a dewar of liquid nitrogen. Now, I've played with cryo before, and it absolutely works. Metallurgically, it is magnificent. So my old story about cryo is that I bought a machinist's vise on eBay, as one does. And it was a student project. It was obviously a student project, but it was nicely done. And when I got it and I measured the hardness, it was hard as Hades. It was hard. So I kind of thought, okay, this was a student project and they never got around to annealing it. Like the term ended, and and it was something. So I'm like, okay, this is an opportunity. So I went ahead and I made a plan. And my plan included doing a cryo treatment on it using dry ice. So I got a block of dry ice. I found a place up at exit 10 here where I could buy blocks of dry ice, not the granules. And I did a dry ice treatment, and I did a tempering, and it came out perfect. I think I'm going by memory here. It went in at Rockwell. It was like 65. It was crazy, and it came out about Rockwell 58. So I tempered first. This is important. I tempered first. I didn't know what I was doing. This was my first time, right? It came down to 58. It went into cryo second. Okay, Keith, I'll catch you later. This will be on YouTube, so if you want to review it. Thanks, man. Thanks for checking in. So it went into cryo for 24 hours, because why not, until my dry ice ran out. And I picked up 2 points. It went back up to 60. And I was very happy. So cryo absolutely does its job, and it does it well. And I'll explain more about why it does that in a second. So we took these parts after I did all the best grinding I could do on them, and then I cryoed them, liquid nitrogen, overnight, 24 hours, and then they came out and they went into a tempering oven at 425, which was 25 degrees lower than the original tempering temperature. And this is what they looked like coming out. Look at the gorgeous color, okay? These were right off the grinder, perfectly shiny. Let me give you a color reference here, okay? There's a color reference. And they came out looking like this, which is exactly what they should look like, and they came out beautiful. Now, here's the thing. They moved. They moved. So here's an example of a part that went in, and it, I have a little notation here that says flip. This guy went in with a frown and came out with a smile. Okay, and it moved a lot. So this guy's got 4.5 thousandths of smile in him, or frown in him. And I didn't expect that from cryo and a temper. So what's happening here? Several things. It's not one thing. It's several things. One is my built-in stresses from my early mechanical straightening. They're still coming out. Okay. But the second thing is, and put your nerd hat on, is that when you do heat treating, the whole purpose of your heat treating is you're converting. You're taking your steel up to red hot, and you have a crystal structure known as austenite. And when you quench it, it becomes martensite. So you want your austenite to convert to martensite, which it does mostly. And the worse your heat treating process sucks, the poorer your conversion rate. So if you have a really crappy conversion rate, you might only have 70% conversion, maybe 80% conversion. If you're doing a super skookum job, you might have 90% conversion. When you cryo a part, okay, and you put it into liquid nitrogen for a couple hours, and now you pull it out, the liquid nitrogen continues the conversion and can take a part that only got converted 90% and turn it into a part that's 99%. Or it could take a part that was 70% and turn it into a part that's 95%. So the cryo treatment is very effective. Why did I bring this up with respect to the part moving? Because austenite is smaller than martensite. So when you do that conversion by quenching and your whole heat treating process, the part actually grows. Somebody's going to correct me if I'm wrong, but I believe that the martensite is a body-centered cubic crystal structure. If you don't know what that means, don't worry about it. Which is necessarily a larger crystal. Okay. So what happens if you have some parts? If you're not converted well and not uniformly, you could have austenite, not Austenite. Thank you, Carl. I knew Carl was going to be on my case for something. I appreciate it. Yeah, I thought of that too. So Paul says, do you think that dunking your parts directly in the dewar introduced stress as opposed to cooling it slowly per applied science process? I didn't see his thing, by the way, but it is entirely possible that's what happened. It's possible. Yeah. I'm chasing all of these variables. It's non-trivial. So yeah, I could have screwed up by just slamming the parts into the liquid nitrogen. A research project for another day. So there's two sources of stresses in the part. There's mechanically introduced stress, and by the way, the stress that you're referring to is essentially a mechanically introduced stress. And then there's crystallographically introduced stress, where the martensite is bigger than the austenite. And so you have two processes here that can be moving the parts around. Do I think the cryo is a good idea? Yes. I think that the mechanical straightening was a bad idea. And if the cryo properly applied introduces a little bit of stress, we'll deal with that in the grind and maybe in the mechanical straightening. All right, moving on. So we talked about the cryo, and we talked about what I consider the problem in the cryo. Finally, we get to final grinding. Now, I've been grinding with a Norton 5SG wheel because I just think it's the greatest thing since sliced bread. But in a conversation with Robin, he correctly points out that the 5SG wheel is not as sharp. Yes. Yeah, we'll talk about that, Carl. Is not as sharp as a plain white wheel, a Type 38A wheel. So the act of grinding, we think of grinding as this very, yes, exactly. So Aaron says, Walla Tool says, that wheel isn't great for thin parts. Guess, light dawns on Marblehead. So, but that was my choice, damn it, and I was sticking to it. So Robin correctly pointed out that a 38A, baby's first wheel, a white wheel, is actually a better choice for the mission. So now let's stop for a second and breathe and think about grinding. When that grinding grit comes along and it pulls a chip up off your part, okay, that is a negative rake process. Nobody's invented a grinding wheel yet that has that has little cutting edges all aligned, ready to do a positive rake. Wes says, sliced bread. Didn't you play bass for them? I did, but after a couple of months of that, I was toast. So there's no grinding wheel that's going to give you a nice positive rake chip like you get on a cutting tool. So it is, on average, this is a negative rake process, which is putting stress into the surface of the part, even though you're grinding it. So this is another source of changing the part stress profile. So yeah, I got learned from Robin as to grinding wheel selection. So if I had to do it all over again, I would stand here wisely telling you how I chose a white wheel because it will not impart as much stress into the part, but I wasn't that smart. In fact, I was pretty stupid. I'm smarter now. So grinding wheel selection is important. We talked about that. Oh, the other trick that we learned, so the paper towel trick, very useful thing for the arsenal, with the proviso that if you have built-in stresses, it's not going to take them out. So when you go to flip it over, you still have some built-in stresses. If you don't have built-in stresses, or if you have very little built-in stress, it's awesome. And theoretically, if you have no built-in stress, it's a one-stop shopping, right? Paper towel trick, flip it, grind it, done. We know how much that happens. We learned about, from Adam Demuth, we learned about the superglue trick. And he, in turn, learned about the superglue trick from Professional Instrument. Or Precision Machining. Professional Instrument. Anyway, you can correct me, Adam, if you're able to. But Adam used the superglue trick in his video. We talked about that. And I played with the superglue trick also. Here's the thing you have to know about the superglue trick. That's a magnet off part holding solution where you put your part down on the magnet in the frown configuration, and you put a couple of dots of superglue to secure the part, and then you go and you do your grinding. Well, first of all, if you're as good a grinding hand as Adam is, you're only taking off a few tenths at that point, as opposed to beating on it with an axe, which is, how I was treating it. So the superglue trick, after playing with it and thinking about it, you still have to realize it is a hard part holding method. In other words, the paper towel trick actually can allow the part to move. The superglue trick does not allow the part to move. But it also doesn't induce any bending because of the magnet. So it is useful, but it was not useful for me in this process. And I did use it. I did play with it. It works. It's a good thing to have in the toolbox, as long as you keep in mind that it is a rigid work holding technique that doesn't use the magnet. And if that's what you want, it's a great trick. Yes, so Walla Tool says another cool trick for warp is using paint marker. Once it is on and dry, you can sand it lightly on a rock surface plate to get it so it's stable and doesn't suck the warp to the chuck. Also, so he's using a paint marker as a shim, and that's brilliant. I'll get to you, Adam. He says also, this is Walla Tool, says also, are you using an actual paper towel? An actual paper towel? Nobody knows. I did not check the pedigree. I tend to use a Kim wipe or a piece of newspaper. Maybe a paper towel is too thick, re your spark out issues. So here's where it gets interesting, Aaron. We have a million choices. Again, right? We're heading into yet another vortex on the paper towel trick. I actually did try I used some of this stuff. Hang on. I have a roll of this brown paper that I have in the shop, and I did try this. This was I was on a steep learning curve, but I didn't like it. Okay. By the way, Adam says newspaper is an endangered species. Adam also said all sales are final, no refund. Listen, Adam, you sold me a tool. I actually like it. Just this process, because I'm still fixing my screw-ups, So I tried brown paper, didn't like it, but don't take that. That's not a final conclusion. That's because of where I was at. So, don't get me wrong. My spark out issues, I'm not complaining. I'm actually bragging. It did the job. To heck with the spark out issues. When I went to measure it, it was 0.3, and that's down from the 5,000ths or whatever it was. So I considered it a wild success, and it is in line with Adam's. It's a 90% solution. So, tool for the toolbox. And yeah, so we could test different materials for the next 6 months, and we'd not be done. So we talked about the super glue trick. We also did the rotate the parts trick, right? So these parts are long, right? So if you run your wheel the long way, you're making heat, and when you're at the center of the part, the heat has a harder time getting out than when you get to near the end of the part. So you're making heat when you grind, no matter what you do. So you could take the parts and rotate them 45 degrees or 30 degrees or whatever on the chuck, so that you're putting less heat in the part per pass. I did that. Of course, that was in the noise for me because I was dealing with other stuff. But that is another trick to put in your toolbox, is to take a long part and rotate it. And that was also shown in multiple places, but Adam showed that on his thin V block video. He also did a rotation of the part to keep the heat out. So we talked about that. We talked about that. And we talked about that. So this has been a very, very interesting voyage. Now, do I need to do as much as I'm doing to make the parts that I'm making for Chris? No. We're going to be done soon. And in fact, I'm probably going to just be taking the parts that I ground and finishing them out for Chris. They'll be fine. You know, if they're within a couple of thousandths, we're good. And I think we can get there without much trouble. But I think there has to be a batch number 3 where we apply all of the lessons we just learned and see how we do. And I will report back. At this point, I will be happy to entertain any questions or comments that you might have. Just put them in the chat on either Instagram or YouTube, and let's see if we can't address them. Either I will be able to answer them, or some of our assembled experts will be able to answer them. But first, I'm going to take a sip of tea while you enjoy my Ox Tools t-shirt. We are at the top of the hour, so at this point, we're just coasting in for a landing. I will remind you, if you're still thinking of a question to type into the chat, that if you don't have PFG stones, what the heck are you doing? Go to pfg.gg and pick yourself up a set. We have most sizes in stock right now. Walla Tool asks, are you running a phase converter? I'm running a business here, sir. Oh, yes, I have. So as I go around the shop, the Vertical Machining Center, the Sharp, has a 10 horsepower phase perfect phase converter. The grinder, whoa, sorry. Keith's in here, by the way. The grinder also has an identical 10 horsepower phase perfect phase converter. Everything else has a VFD on it. Walla Tool, I said everybody should have a set of PFG stones, and Walla Tool correctly points out, or 3 sets of PFG stones like me. Thank you. You are a dedicated customer, and I appreciate it. Yeah, they each have their own. So I have 2 10 horsepower converters. One is dedicated to the Vertical Machining Center. One is dedicated to the Okamoto grinder. It's overkill, but we like overkill. Bridgeport has a VFD on it. Bandsaw, which is not back in service, is getting a VFD on it. What else am I missing? Oh, the Haas TL1 has its own VFD in it. So actually, it comes from the factory, ready for single phase, and that's it. Everything else is single phase. A word about VFD converters. VFD converters are meant to be married to a motor. They're not meant to be switched between the VFD and the motor. Be careful. You can blow up a VFD if you try to switch it on its output. It's designed to be married to the motor. Excellent question. Any other questions today? We had a really nice customer. Oh, I could make an announcement. We had a really nice customer in Poland that I just sent a whole bunch of stones to for their business. And I finally figured out international shipments with respect to customs. And I have a previous customer that's getting an apology because I didn't understand this back then and I thought I was being yanked around. On the customs forms, they require a tax number. Well, if you're a sole proprietorship, Henry says, is there no three-phase available for houses in the United States? No, Henry. That in the United States, domestic electricity is single phase. I know you guys have three-phase to the house. And only in an industrial setting do you get three-phase to the building. So the customs form asks for a tax ID number. And as a sole proprietor, I interpret that as meaning my Social Security number. So I had a former customer that was, our accountant needs your number, which I interpreted to mean my Social Security number. And I told him, I said, look, I'm not going to give you my Social Security number. It doesn't make any sense. So I didn't. Well, now I come to find out that it could be an EIN number. So here's the thing I learned from a small business point of view. And by the way, before you run away, some of you are checking out. I have a book recommendation in a second. So you can go to the IRS, and even as a sole proprietor, underneath your Social Security number, you can get an EIN number just for asking. And then you could use that EIN number where you need to use it, such as international shipping for customs. Okay? So we got the customer I just shipped to recently, he was the one who triggered the solution, and we're all set. And that number is now on the website. Oh yeah, 23 grand. Absolutely. So I actually had it good in my last house. I was on a road that had a major feeder on it, and it would have only cost me $3,500 to have three-phase into my old shop. I never did it. I'm glad I didn't do it, because then you have infrastructure, which is an additional expense. Yeah. There you go. 400 volts, 60 amps, three-phase for everybody. Isn't that crazy? All right. Last thing today, because I forgot to do it earlier. This book, Knife Engineering by Laren Thomas. Also see his YouTube channel. Just look for Knife Steel Nerds. And highly recommended. You can tell I found some cool information that has informed my process and has added knowledge. I don't remember who recommended this book first, but it's a good book. It says knife engineering, but steels and heat treating, and it's just awesome. Cryo and Austenite to Martensite conversions. Okay. Well, I'm going to call it. You guys are awesome. It's only 2 minutes after the hour, which is better than we did last week. We'll see you guys next week. If you have any requests for discussions or content or anything else, let me know. There's a possibility of a random live later today, but otherwise I'm going to go give my voice a rest. So you guys take care. Bob Lab says, what are these books you speak of, Earthling? It is entirely possible that that book is available electronically, but I'll tell you something. I am still in the land of highlighting. I like my highlights and scribbling and notes. Speaking of electric cars, and those of you that hung in here get one little tidbit. This is like church for machinists. That's funnier than you know. Yeah, let me know, Paul. I ordered an electric vehicle. That's all I'm going to say. It's on order, and I'll have more to tell you about in the future. How's that for a teaser? It's not a bad teaser. All right, guys. Go make something. Go learn something. And maybe help somebody else learn something, too. Have an awesome weekend, and we'll see you guys next week.